Hello. Today it's all about the world's biggest flame test. This is like a super cool thing that I'm very excited to share with you. So, first of all, what exactly is a flame test? Well, here's the idea. Matter is made up of elements. Every element, as you can see behind me in the periodic table, kind of has its own number of protons, which means its unique number of electrons as well. And what makes color? Well, if we excite those electrons and they go up a level, and sort of this valence level, if you can think of it that way, and then when it comes back down a level to what's called its ground state from its excited state, it gives off light. Well, if you think about this, if every element is different and every element has sort of different electrons in different places, they give off different light. And the really cool part about this is it can be used, that light or spectral pattern that we see, it can be used as a fingerprint for that element. So, how can we use this? Well, here's a really cool way to use it. So, light buckets, this is basically a fancy term for giant telescopes. Now, back in the day, if you wanted to be an astronomer, you'd have to get a PhD, travel halfway around the world, spend a couple months at a telescope, hope for good weather, and to collect data. But now we can actually do it on the internet for a little bit of money. You can actually rent time on a telescope anywhere in the world. It's the price is dropping like crazy, and you can say, "Hey, by the way, could you please look at this object for me?" Which is what I did. So the one object we're going to look at is something called M27. M stands for Messier, who was a gentleman who, in the France, when people were finding comets, he used his backyard telescope to find all kinds of things that weren't comets, and he has this catalog of over 100 things that you can see in your backyard. Now, this is a gas cloud that's really far away, like a couple like thousands of light years away. Sorry, hundreds of light years away. And if I were to travel from this end of this cloud to this end, traveling at the speed of light, it would take me at least 100 years traveling 186,000 miles every second, right? So this is really far away. And if I try and view this in my backyard in Mason, Ohio, on my telescope, which is a pretty decent one, it looks like a little smudge that I can barely see. The Hubble telescope, when it was around, did a great job viewing this very easily, and they actually assigned artificial colors to it, which we'll see here in a minute. So, this is what you would see just with no filters, and this is kind of what we see if we had the perfect backyard telescope. So then what I did is I said, hey, instead of looking at everything here, basically I said, look, only look at the element hydrogen. So hydrogen it's excited. It's one electron's going up a level, come back down a level, giving off light. And it's only a specific type of light. And so the filter only captures that light. And as expected, this giant gas cloud here, this nebula, has a lot of hydrogen. It's the number one element in the universe that makes up stars. No surprise. We can start to see a few things. It looks like there's a spike right here. There's a little wedge here, maybe a bit wedge here. You can see a little bit wisp of hydrogen gas on the outside. Hey, let's keep on going. What if we were to say, let's only look at oxygen? What? There's oxygen here as well, and it looks a lot different than what we're seeing with the hydrogen. I think I can kind of go back here real quick. There's hydrogen, and sure enough, there's the oxygen. So you can see that there are differences. Why stop there? So now the next one said, let's take a look at, and I know this is kind of in the way, I believe this is sulfur. And it's weird because now we're seeing we've blocked out all of the other light from all the other elements. We're only seeing the light that the sulfur gives off if it's present. We know it's present hundreds of light years away. And you see that you're starting to see like this axis here. So the heavy stuff is kind of in the center. So it's pretty cool because ultimately what we have here, based on this flame test, is astronomers can take a quick look and say, maybe we can start coming up with theories on how planets and stars are forming, even though there's no possible way that we could ever get there on a spaceship. And the really cool thing is all of the elements that you see. So, like all of these back here, you know, whether we're anything on Earth or anything like millions of light years away, this is it. Like this little thing right here, this is it. And these flame tests work if it's hundreds of light years away, or if you discover a new element like my gal here did, Marie Curie. How did she identify it? One test, she used a flame test. They saw light that they never saw before and said, guess what? It's a new element. Pretty darn incredible. That is the world's biggest flame test.